All right, it's Mr. Ryan, and we're going to continue our conversation about vectors here. What I want to do in this video is I want to show you very easily how to identify the magnitude of a vector if you are told what the components of the vector are. And you could be told the components of the vector in a couple different ways. You might simply be told that vector B vector B has the components, let's say 9 and -4. Or you could be given a graph with an arrow on it, and you could be told that this is vector C and that it has the components 4 and 3. So you can either be given a graph, or you might even be given, maybe you're not given the coordinates, you might be given a coordinate plane with a grid, and you have to count 1, 2, 3, 4, 1, 2, 3. And then you know that the end of the arrowhead is at the point 4 and 3. But somehow or another, you have to be given a way to know what the components of the vector are. Once you know the components of the vector, you can then calculate the magnitude of the vector. So it's really, really simple. Watch this. Do you see this vector right here? This vector, the length of the line is basically, watch this, it's basically a hypotenuse of a right triangle. Look at that. It's the hypotenuse of a right triangle. In fact, any distance between 2 points, any diagonal distance between 2 points on a coordinate plane is always a hypotenuse. If I had a point here and another point here, and I wanted to know the distance between those 2 points, I could very simply draw a right triangle. Whoops, that wasn't very good. There we go. I could draw a right triangle, and now all I have to calculate is the length of a hypotenuse. Well, how do I find the length of a hypotenuse? With the Pythagorean theorem, right? So my hypotenuse, C, well, I know that C squared is going to be equal to A squared plus B squared. And in this case, the two legs of the right triangle are the components of the vector. See, look. This component, the x component, is from here to here, that's 4. And the 3 component, the y component, that's the vertical component, 3. Those are the legs of a right triangle. And so the length of the hypotenuse is just simply the Pythagorean theorem using 4 and 3. Now this is actually another special kind of right triangle called a 3, 4, 5 right triangle. So I happen to know that the magnitude of this vector, that the magnitude of vector C is 5. But let me prove it to you, okay? I'm going to use A squared plus B squared equals C squared. And actually, really what this is going to be the magnitude of vector C squared. Okay? So look, we're going to put, let's call this A and this B. We're going to put 4 in for A, so we got 4 squared, plus we'll put a 3 in for B. 3 squared is equal to the square of the magnitude of vector C. Okay? And so 4 squared, that's 16. 3 squared, that's 9. And so this is going to be vector C, the magnitude squared. 16 plus 9, that equals 25. And so to get rid of this square here, I have to do the square root of. And to do the square root of this, I got to do the square root of this. And the square root of 25 is 5. And the square root of a square, that cancels the square. And all I have left is the magnitude of vector C. So, bottom line, to find the magnitude of any vector, if you know the components of the vector, all you have to do is square both of the components, add them together, and take the square root. So let's do this vector B right here. If we want to identify the magnitude of vector B, all we have to do is take the square root of the first component, 9 squared, plus the second component, -4 squared. So that's the square root of 9 squared is 81, -4 squared is 16, 81 plus 16, that's 97. That can't be reduced, so the magnitude of vector B is just simply the square root of 97. Okay? Let's try a couple more examples. Okay, I have two examples here. One of them is a graph, and one of them is all I did is just give you the components. Okay? In case you can't see here, there's little hash marks here. This is 1, 2, 3, 4, 5. And then we go 1, 2, and the point is right there, okay? So why don't you pause the video and see if you can identify the magnitude of this vector and the magnitude of this vector. All right, the magnitude of this vector. Well, the components of vector A here are 5 and 2, okay? And the components of vector R are -3 and 7. So in order to identify the magnitude of vector A, we'll put vector A in some absolute value symbols, equals, and then all we have to do is we're going to do the square root of that squared plus that squared. So 5 squared plus 2 squared. So the magnitude of vector A is going to be equal to the square root of 25, that's 25, 5 squared, plus 2 squared is 4, so 25 plus 4 is 29. Now, if it could be reduced, we would reduce it, but the square root of 29 cannot be reduced, and therefore we're just going to say that the magnitude of vector A is the square root of 29. Now let's come over here and find the magnitude of vector R. The magnitude of vector R is basically just the square root of that number squared plus that number squared. I'm going to put it in parentheses because it's a negative value. So -3 quantity squared plus 7 squared, right? And so -3 times -3, that's 9, and 7 squared, that's 49. And so, oops, that's not a squared, that's supposed to be an arrow. It's going so fast. The magnitude of vector R is going to be the square root of 9 plus 49, which is the square root of 58. Let's see, 58. Do 29, nope, not reducible. So we're just going to say the square root of 58. So the magnitude of vector R is the square root of 58. Now let's say, just for the sake of argument, that we have vector W, and we have the magnitude, and the final answer is the square root of 12. Let's say that the final answer is the square root of 12. This square root of 12 is reducible because 12 can be reduced into the square root of 4 times the square root of 3, and you should go ahead and reduce that. And the square root of 4 is 2. So this is actually 2 times the square root of 3. So the magnitude of vector W would be 2 and the square root of 3. Okay? Let's just do a couple more examples. All right, here's a couple more examples. We've got vector S here and vector V here. Here's the components of vector V, -1 and 3. And what are the components of vector S here? We're going to the left 2 and we're going down 4. So that means that the components here look like -2 and -4. So vector S is the components -2 and -4. If you want to go ahead and pause the video and try these out, try to find the magnitude of each of these vectors, that'll help you a lot. All right, so let's do this one first. The magnitude of vector S is going to be the square root of that number squared plus that number squared. So parenthesis -2, then we'll square, plus parenthesis -4, and then we'll square. And so this is going to be the square root of -2 times -2, that's 4, and -4 times -4, that's 16. So that's going to be 4 plus 16. So the magnitude of vector S is going to be the square root of 20. Now, 20 is reducible because 20 can be broken down, can be factored down into the square root of 4 times the square root of 5, right? Because 4 times 5 is 20. And so the square root of 4 is 2, and then we just put on a square root of 5. So really the magnitude of vector S is 2 square root of 5. Let's try vector v over here. The magnitude of vector v is going to be equal to the square root of this number squared plus this number squared. So put parenthesis, -1 squared plus 3 squared. And that's going to be the square root of -1 times -1, well, that's 1. 3 times 3, that's 9, so 1 plus 9. So the magnitude of vector v would be the square root of 10. And that is not reducible. Note that every single time here our answer is a positive number because all magnitudes are positive numbers. Okay, that's it for magnitudes. I'm only going to show you one more thing about vectors. I'm going to show you how to identify the components of a vector when you're given the magnitude and a degree angle of the vector.